now it's time to add AI cars. We will create a script to handle this. So let's make a new folder, call it AI, and then create a new C# script, and we will call that AI car spawner. So that script will be responsible for spawning AI cars. So let's open it in Visual Studio. The AI car spawner will be similar to our endless section handler, which spawns different sections. So we first of all have a serials field of a game object, which is an array, so that we can have multiple different AI cars. Then we will need a pool for this as well, so that we can run it more efficiently. And we'll create an array of car AI pool, which is a game object, and we'll make it a size of 20. So now that we have our pool, we can actually start to populate that pool. So let's do it in the same way that we did it before. So in the start menu, let's have a prefab index so we can loop through the car and have different cars in our pool. And then let's create our pool. So we will have a for loop in this case, and we will loop from I0 until the length of the car pool. And then we need to instantiate our car AI prefab here. So let's instantiate and take the prefab index and then just store it as the car AI pool. And once we have done that, we want to ensure that this car object that we have just spawned is not active. So let's set it to active false. And then we will increase our prefab index, so it takes the next car in this array. And if we are going beyond, so let's say that we have one car here and the prefab index becomes, well, 2 or more, then it's going to throw an error. So if we are going outside the array, if prefab index is larger than the prefab length -1, then put it to 0. So that will ensure that we are staying within this array at all times. So after we have run this, we will then have 20 AI cars that are ready for us to use. Then we will get rid of our update function, because we will replace it with an update less often coroutine. And the reason why we do this is to save a little bit of performance. We don't need to check to spawn cars all the time. Rather, we can do it a little bit less frequently than the regular update function. And we need a time for this. And instead of creating it here, we'll do it once to save the garbage collection. So wait for a second, wait is equal to new wait for second 0.5. This generates garbage if we run it all the time, so we just run it once because we will wait for exactly the same period of time every time. So then in our update less often, we need to make sure that it runs at all times, so while true, and then we will yield, return, and then use our wait that we have created up here. Then we need to as well start this. So let's do start coroutine and then the function. So now we are running that function, and from this function we will do a few things. The first thing is that we will create a new function called spawn new cars, and this of course needs to run, and we will run it after or actually directly spawn new cars. And this function as well will need a bit of timing, so that we know that we're not spawning all the cars at the same time with just a delay of 0.5, because that will, well, fill up the screen very quickly with 20 cars at similar locations. So what we will do instead is that we will create a time variable, so that we can keep track of how often we have spawned cars. So we'll add a float time last car spawned, So that will be the time when a car was spawned. And we will check here in our spawn cars if it is time to actually spawn a car. So what we will do is we will check if the time minus time last car spawned is less than 2. So if it's less than 2 seconds, we are just going to exit the function. We're not going to do anything. But if it's more than 2, then we want to spawn a car, and at the end of the function we're going to store the time so that we remember that. So now that we have started to run this function, we want to find a car. So let's find a car to spawn. We'll create a game object, car to spawn, and we'll put it to null. Then we want to find a suitable car in our car pool. So let's loop through our car pool here with a for each loop. So we'll do a for each game object AI car in car AI pool. So that loops through the car AI pool. And the criteria for this is that we only want to find a car that is active. So we don't want any of the inactive ones. So let's skip the active cars. So we'll check if car AI car is active in hierarchy, then we are continuing. So we're skipping that one until we find a car that is actually available. And in that case, we are going to store that as car to spawn, and then we'll break this for loop. So we will exit the for loop. So once we have reached this point, so either we have found a car or we have looped through our whole array and we haven't found a single car that is available. So we need to check if the car to spawn is null. If it's null, it means that we have gone through the whole car pool and we haven't found one. In that case, we are just returning. So then we want to spawn our AI car, and we want it to spawn ahead of the player's car. So in order to do that, we need to find out where is the player's car. So we need to find the player first. So let's actually just add that one, and let's move this one to timing actually. So now we have player car transform, and we need to find this one. So let's do it as we did it before in the start function. Let's just find game object, find game object with tag player, and take the transform of that. So then we have the player's transform. And now we can use that in our spawn method to check that where the car is at. So let's create a new vector 3. We'll call it spawn position, and let's assign it to a new vector. And the new vector will be new vector 3 0. So we'll spawn it at x position 0 and y position 0, and then we will take the player's car transform position in the z direction, and we will add 100 to it. So we will spawn ahead with 100 units. And then we will take our players, the car to spawn, and we will take the transforms position and put it to the spawn position. So that will force this car to move into that position, and then we simply set it to active. So that will move the car into the correct position, and it will activate it. We also want to reuse our AI cars, either when the player is passing the cars or if for some reason the AI cars are getting too far ahead. In that case, we need to just reuse them. So we will create a new function, void cleanup cars beyond view, and it will loop through our AI cars like we did before with a for each loop. And it will do the reverse thing. It will skip any inactive cars, so it will just focus on the active cars. And then we will check if the AI car is too far ahead. So we'll take the AI car, transforms position Z minus the player's car's position in Z. And if it's above 200, so the car has driven too far ahead, then we just want to disable it. So we'll set it to active false. And then we do the same thing in the reverse direction. So if we are passing an AI car, so we'll take the AI car's position in the Z direction minus the player's car. And if it's less than 50, then we are going to set it to active false. Oops, there we go, active false. And then we need to run this function as well. So after actually let's do it before. So we'll clean up before, and then we'll spawn new cars, and then we will wait for a rerun and then run again. So let's save this and try it in Unity and see what happens. So in Unity, let's take our car here. We need to create a prefab from it. So let's create a folder for it and call it cars. And then let's do this. We'll call it car base prefab. And then we have that as the player's car. And we will use the same car for the AI. So the AI will use, well, the same functions, and we need to replace the input handler with an AI car handler, but we'll do that in a bit. For now, let's just change this to car AI. And let's change our tag here to be car AI. And then drag it, oops, where did that go? Cars, here we go. Drag it again, and in this case we're going to do a prefab variant. So the prefab variant is then based on this. So actually we'll need to get back our player car, and now I probably messed up the virtual camera, which I did, yeah. So let's just assign those. Okay, so now we're back with that. And our main camera, let's take our AI spawner that we just created and attach it there. And then we'll need our AI car prefabs here, prefab and cars, and then take the AI prefab and drop it in there. Okay, so now if we take this for a spin, we should get some AI cars. And if we look at the scene view, we can see that, okay, we have our AI cars here. And they exploded. So why did they explode? Well, the reason why they exploded is because they actually hit some collider, which caused them to explode. So that's not something we want. We only want the player car to explode. The AI car should explode if they are getting hit by the player or some other maybe car part here. But we don't want the AI to sort of explode if they are hitting each other or some other game object. So we're cheating a little bit, but it makes it a lot easier, because we might have cases when they are sort of bumping into each other a little bit, and we don't want the whole level to sort of explode because of that, which will make it very hard for the player to navigate through the different car debris. But it could be a game mechanic, I guess. But in this case, we're gonna make sure that they can't explode whenever they're hitting some other object except for the player or some other little part here. So to make that work, we need to create a new tag so we can differentiate between a car and a car part. So let's add a tag for that, and we'll call it car part. So now we have the different parts that will get this tag, but we will change that in the code as well. So let's actually go back into our Visual Studio, and let's open the car handler. And the car handler contains our code that handles the case when we are slamming into things and we are exploding. So let's actually delete this hit, because we now know that this code works. What we want to do is we want to limit the AI, so that the AI does not work in the same way. It will only work if we are hitting the player or one of the car parts. So we need to differentiate if we're the player or not. So let's add a bool is player, which is true as a start, and then we will make sure that it can handle AIs. So if we are assigning is player is equal to compare tag player. So if we're the player, it becomes true. If we're not the player, it becomes false. And then in our on collision enter here, we want to check if we are the player's car or not. So let's add a check for that. Oops, here we go. If it's not player, so if we're not the player, we want to check what we are hitting. And if we are hitting the untagged, so something that has not been tagged with anything, that is most things in the game world, then we will just return. We won't do anything with it. And if we are hitting our own AI cars, so let's check car AI, and in that case we are returning as well. So that will filter out any collisions with the world or the other car AIs. Okay, but then we have the different car parts, right? So we said before that we want them to be able to, well, the AI car to be able to react to whenever we are hitting something. And the car parts now have the tag untagged, so they won't work. So let's go into our explode handler, and after we have changed everything with our rigid body, let's actually change our game objects tag to car part. So that will cause it to change, and then we will be able to catch it in this case, or actually in the car handler, because in this case it won't be untagged anymore and it won't be car AI, so it will actually react and explode. Okay, so let's save that and go back into Unity and try it again. So let's try it again. And let's have a look at the scene view. So now we have an AI car here, and it did spawn. So that works okay. But of course it doesn't drive yet because we haven't added any code for that. And now we're getting multiple cars and they're all spawning on top of each other, which is not something that we want. So we need to be able to have a check as well that the area that it's spawning on is actually cleared. So we need to check the area and make sure that no other cars or other things are sort of in that general area. But we're mostly interested in the cars in this case. It doesn't really matter if the environment is like the ground or anything else that you have a collider is in the way. So we will make sure that we're just considering cars. So we need to be able to differentiate between a car and something else. So in our layer we need to add a new layer, and let's call it car. And our car base here, let's assign car, or actually let's do it from the prefab. And let's change the layer here, car, yes, change children. And that will change the layer to car. And then we will be able to select the cars and not the environment. So let's go back into our script and our AI car spawner and open that in Visual Studio. So now we need to be able to check the area if we're spawning on top of something else. So we will do that with an overlap check. And for that we need to be able to specify what layer mask we're going to use. So let's make a serialized field, layer mask, and call it other cars layer mask. And we'll, let's add a collision here so we know that, or actually overlapped check. So, we will use the non-allocate function, which is doesn't produce any garbage. And that means we need to supply a collider. So let's make a collider array, call it overlapped check collider, and make it a size of 1, because it only takes one car to be in the way for us not to want to spawn in that location. So let's check our code here. So we have our spawn new cars, and when we have found a car that we want to use, we have gotten a spawn location, and in this case we need to check this spawn location if it's okay or not. So let's add a check for that. So we're going to do if, and then we'll add oops, copied the wrong code here. Hold on. So we're going to do physics overlap non-allocate, and then it takes in a center. So the center is going to be the spawn position of our car, and then we have this half extents. So that's a box with a half sized, and for us we are going to check a little bit bigger than just a size 1 box. The car is approximately 1 unit large, and we're going to feed it with half of that. So if we would want it to be exactly the same size of the car, we would take the vector 1 here and make it half. But we want to check a larger area, so we're going to multiply it by 2, which makes us check both in the sort of the width of the whole area of the road, but also a bit forward and backwards of the car. And then this function takes in our collider, our overlapped collider, and then we as well we need to specify the quaternion, so the rotation of this box, and it's just going to be unrotated. So let's add an identity, quaternion identity, and then we have our layer mask. So add layer mask, and for now we actually don't really care about what we have found here. We only care that if this is larger than 0, it means that we have hit something. And if we have hit something, then we are not interested in continuing spawning because something is in the way. So in that case, we are just going to return, and hopefully later on, either our player is moving forward or that car is moving out of the way. So we are going to be sort of a little bit naive and not try to pick another location. You could change this to, for instance, be a little bit even further ahead of the car or player car, or more sort of closer to it, but make sure that it's quite far ahead, because otherwise it will look a little bit strange. Because right now we're spawning on location 0, or in the y direction 0, which means that the car is actually floating above the terrain, because the terrain is being moved upwards. You can change the AI car to align itself with the terrain, so when the terrain is moving up, the car will move up. But you might have issues where the different cars in that case might sort of collide with each other because of the height difference. So I actually put everything on 0, and yes, there might be, like, if you're going against an overhead or an overpass, you might actually hit that and the car might stop, or, well, you need to take care of that in your code and check that it really actually works. But for now, we'll put it at 0, and that's the easiest solution. So let's save this and go back into Unity. Then we need to add our layer. So let's go into AI car spawner, and then other cars layer mask here, add car to it, so it knows what to check for. And then let's try it. So if we go into our scene view and wait a bit, so we have this car now, and yeah, we can see that it's floating above the ground, which is perfectly fine, because this ground will move upward as the player is moving forward, and the player is, well, way over there. So actually now nothing is spawning on top of it. We can see that we don't have another one, which is great. So if this would move forward, then eventually we'll have a car that pops up there. And we can try it as well to the side and see that, yeah, if it's close to the road here, it won't spawn, but if we get way to the side, which we want, it should eventually spawn. But let's just move it forward and see where it triggers. If we are happy with that, see, this is the distance that it approximately triggers on, which is a good distance, and we'll keep it as is. So now, however, when we are driving, all of the cars react to our input, and we are driving all the cars, which is yeah, cool in a way, but we need the AI to have its own code. Let's create a script for the AI. So a new C# script, AI handler, and let's open it in Visual Studio. Now this is a preference that I have, but I like to add all of my scripts to my main prefab, the base car, and then have the scripts select if they should be active or not, or destroyed or not, based on if they fit a certain behavior. So in this case I'm going to do awake, and in our awake I'm going to check if we are the player, then we are going to destroy this script and return. So it means that if we are running as the AI, then it will continue and the script will be able to run. But if we are the player, then it means that we are going to destroy this. And we need to do the opposite with our input handler. So let's add that, and in the awake. And then if we are not the player, then we're going to destroy this. So then we have a method of handling this. Another way of doing it is that in your AI variant, you can remove those scripts and make sure that they are only the AI handler is active and not the input handler, but I prefer to do this way. And then of course our AI needs to be able to drive our car, and we are not going to cheat. We are going to have the AI use the same steering as the player. Another way of doing it is that you have the different steering that maybe doesn't rotate the car or whatever, but we are going to use the same way, which I personally often like more. And the car handler, we can make it as a serialized field so that we are assigning it, or we can find it in the awake. But let's use a serialized field, so we are assigning it through the inspector. And then we want to set some type of speed. So let's do events. So we want the AI cars to drive at different speeds. So whenever they are becoming enabled, we want them to pick some random speed value. So we have on enable, and we need in this case our car handler to be able to change the speed, right? So right now we have this in our car handler. We have our max forward velocity, which is 30, which is quite fast. So we need a function to be able to set this. So let's add a function for that. So we'll add here, we have set input, so that's a pretty logical place. So let's add a public void set max speed, take in a float new max speed, change the max forward velocity to the new max speed. So let's save that and go back to our AI handler, and our AI handler in this case is going to take our car handler and use set max speed, and the maximum speed is going to be a random, and we'll put it between some small value, like let's make it between 2 and 4. So the car AI, when it's getting enabled, will set its maximum speed to 2 or 4. And then we need it to drive forward, right? So in our update function, we needed to take control of the car. So let's just put the acceleration input to 1 as a start. And then we have the steering input, which will be 0 as a start. And then we will make sure that this steering input is staying between -1 and 1. And we'll clamp it to that just to make sure that it's not going beyond those. I think we had a check for it anyway, but yeah, let's do that. And then we need to make sure that our car handler is getting these values. So let's take our car handler, set input, make a new vector2 of the steer input and acceleration input. So if we run this code right now, it would drive the car straight ahead, and it wouldn't do very much other than that. But as a start, at least we want it to be able to react to other cars so that it tries to slow down as it's approaching another car. And in that case, we need to be able to detect other cars. And we will do it in a similar way that we did with the overlap checking, but we will use a raycast instead. And we'll add a raycast hit, and we will use this as the same way to not produce any garbage. We're using the non-alloc function, which means that we need to allocate an array for ourselves, and we're only interested if there's one car ahead, because that's enough for us to actually slow down. And let's add so that we are documenting what we're doing with our code. And then we as well will create a variable boolean is car ahead, so that we know that it's when this is happening. So our raycasts takes a little bit performance, which means that we are going to do the same thing as we did before. We are going to run this not every frame. We are going to run it at a set interval. So let's add wait for seconds, call it wait, new wait for seconds, and 0.2. That will be enough at the speed that they're driving to check if there's something ahead. If you have really fast cars, you may need to reduce this value so that they are reacting in time. So we need to create a coroutine in this case, and we'll use the same method as we had before, or same naming. So let's add an update less often coroutine, and while it's true, let's yield return wait, and then we need to start this function as well, start coroutine. Okay, so now we have started the coroutine, and we need to do something. So what we will be doing is we'll be gonna check if there is a car ahead. So let's create a function for that. Bool check if other car is ahead. And we need as well our layer mask, so that we can figure out what cars are we checking for. So let's add a serialized field for that as well. And we can actually put it there. Serialized field, layer mask, other cars, layer masks. So similar to what we did with the overlap check before. Then in our function, actually, when I think about it, we need to do one more thing. We need to have our mesh collider, because when we are checking something, if it's ahead with a raycast, there is a high risk that we are hitting our own object. So we need to actually be able to filter that out. So let's add another serialized field for it, and take in a mesh collider. So now we can actually start with coding our function for this. So the first thing that we are doing is we're taking our mesh collider and we're disabling it. Then we are going to run our physics check. So let's do int number of hits is equal to physics box cast non-allocate. So we're throwing, think of it this way, we're throwing a small box ahead of the car in the forward direction of the car and checking if there is anything ahead of it. And we're only interested in other cars. So we'll start from the car's position, and then we have this, okay, how big is the box going to be? And in this case, we actually only want it to be the size of the car, right? Or even a little bit smaller than the car. So if we have the vector 1, but we have the half extent, so if we take it times 0.5, then it means that it's exactly the same size of the car, but we want it to be a little bit tinier. So we're taking a quarter of that size, which I think will work quite well. And then we have the direction, which will be the transform forward. And the transform forward, and then what do we have after that? We're going to have our raycast hits. Then we want to be able to define what layer mask, so that we need to specify that the quaternion, the rotation of our box, is going to be identity, so it's non-rotated. Then we are taking our max distance, which is how far are going to cast ahead, and we are going to look quite closely. Again, if you have really fast cars, maybe this distance needs to be larger. And then add our layer mask to that. So now we will get a number of hits, but as we have provided one raycast hit here, it's just going to be one. But if you're for some reason want to know more about the cars, or take in multiple cars and handle overtaking or whatever, then you might need to increase that value. Once we have done our check here, it's important that we enable our mesh collider again, so other objects can collide with this. And then we are just going to check the number of hits here. So if the number of hits is larger than 0, then we are returning true. And in all other cases, we are returning false. And then we need to run this function. So check if other car is ahead. So this only updates the, or actually we need to assign it here. Here we go, is car ahead. So that updates this variable, and then we need to figure out what we should do with it. So we have provided our acceleration and steer input here. So if we start with acceleration, if a car is ahead, then we are going to brake. Put the acceleration input to -1. And then we can worry about the steering a little bit later. But let's just try this and see that it actually works in Unity. Let's open our car base here, drag and drop our AI handler, and then we have our car handler, which just be this script and cars, and then we need our mesh collider, which is apparently not there. It's here. Okay, so then we can save that and take it for a spin. So now we can drive our car, great. And if we are looking at the AI car, we can see that, yay, they are driving. So let's go back, and actually we saw them stopping already, but let's make a car jam. So we'll take the first car here. Let's disable the car AI handler. Let's put some drag on it so it stops. And let's have a look at our... obviously didn't save, so drag 100. Oh, the car handler will change that as well. So here we go. So now we've created a nice car jam. They are stopping, and they are able to react to, well, cars ahead. So that's cool. But I mean, this game is not going to be very fun if they're just driving on the center part of the road here, and I can just stay here and I'm just gonna pass them all. And yeah, it's not that fun, right? So we need them to spread out and drive in the different lanes that exist. So we need to be able to handle lanes and all that part. I actually crashed into a car and that seemed to work. So that's good. As in the future, other scripts may be interested to know about the different lanes which the AI cars can drive in. Maybe you want to spawn power-ups, etc. And in that case, we need to have that sort of not in our AI script, but rather let's make a util script. So you could put this as well in your game manager, but I prefer right now to make a utils script. And let's open that in Visual Studio. So this is just going to be a public static class, and it's not going to be a mono behavior. There we go. And what we want is we want some type of car lanes. So we're going to make an array with a static float array car lanes, and then we are going to say that where is the center part of this car lane. So the first car lane is going to be on minus 0.3, so to the left. The other car lane is going to be 0.3 to the right. And if you have multiple car lanes, maybe you want 3, 4, 5, it doesn't really matter, you can just add them here. And then we need to be able to get this, so either we could just make it public static float, but instead let's just make a getter for it. So public static float car lanes, which returns our car lanes here. So this is how you would write that. It becomes a property in this case. So now that we have that, we can use it in our actually our AI car spawner. If we don't want the cars to spawn in the sort of the center lane, maybe we want them to spawn specifically to the left or right or random, but let's leave them in the center at first. So now that we actually have some information about lanes, let's see, let's add that here. The car AI in this case need to know what lane it's driving in. So we'll start with driving in lane 0, and in the same way that we did here, we are going to say that okay, whenever it's getting enabled again, we are going to set some random lane. So the random lane, driving in lane, will be a random range between 0 and the length of our utils car lane's length. So now that we actually have selected which car lane are we going to drive in, we need the AI to handle that. So first of all, we need to find out, okay, what before we are steering here, we need to figure out the desired position in the X direction. So it's where the AI wants to be. And we'll take utils car lanes and then just take whatever driving lane in lane it has. And this will, in that case, just be sort of minus, I don't remember what it was, 0.3 and positive 0.3. And then we figure out, okay, what is the difference? What's the difference between where the player's car's transform is, and we'll take that minus desired position X. So then we'll get a difference. And to avoid like the AI cars making minor adjustments, we are going to say that, okay, we are only interested if our math absolute value of the difference is larger than 0.5. So if it's larger than 0.5 in any direction, we are going to act on it. And how are we going to act on it? Well, we are simply going to take our steer input and just take it at 1.0 and multiply it with the difference. So if the difference is, let's say 3, just to take a value, then it's going to be 3 and it's going to be clamped down to 3, which means the car is going to go right, or it's going to be clamped down to 1. But if the difference is small, let's say it's 0.1, then this steering input will be less, so the car will not sort of oversteer that dramatically. So this is a simple way of handling that. You could have other ways as well to make it even a little bit smarter, but yeah, this works for our case. So let's save this and try it in Unity and see how it behaves. So now let's view our scene view, and yeah, there we have an AI car, and it moved into the right lane, and this one appears to be in the left lane. So yay, our code is working. We can right click our inspector here, select debug, and we can look at the AI car here and its variable, and we can see driving in lane 1, which is the second object or object in the array, which is to the right, so that's correct. And this one is driving in lane 0, which is the left one. So yay, code working. So now we can drive and see how it looks in the game. And as we can see, we have almost like a traffic jam ahead. And yeah, now we have a more interesting gameplay loop where we actually need to mine the cars, and they are getting respawned all the time. And if we hit one of them, they are going to explode as well. And let's actually restart and see if we can get a few of them in a row, and maybe we can see that the car parts are also exploding the AI cars. So let's see if we manage to hit some of these. And well, that car was very lucky. No, we managed to hit it. So yeah, now we have this slowdown, but the code is slowing down with all of the cars as soon as there is an impact, which is cool, but maybe you want to change that so the slowdown only happens when the player car is actually hitting something. And as well, there's sort of a bug if we are hitting this and we're pressing R, we are not resetting the time. So that's something that we need to take care of in our code, that we actually reset our time to 1 whenever we are hitting something. But yeah, that's something that you can change on your own for sure. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. Thanks for watching, and don't forget to like and subscribe. I'll see you in the next video.